Hello M3, this is Teacher Bean and welcome to another video about chemical reactions. For this video, we are going to learn about covalent bond. Before we begin, I want you to prepare your periodic table. So let me just share to you why do atoms form bonds. So in our previous video, this is your atom model. Wherein this first circle here is your first orbital shell. The second ring here is your second orbital shell, and then the third ring here is your third orbital shell. Wherein, in your first orbital shell, so it can hold up to how many electrons? 2 electrons. So you have 1 and 2. In your second ring, it can hold up to 8 electrons. And with your third ring, it can also hold up to 8 electrons. So going back to our question, so why do atoms form bonds? Because the atoms of the noble gases, so what are these noble gases? These are your group 8 gases. Your group 8 gases like your helium, your radon, your xenon. So, in your noble gases, they have this completely full outer shells and so are stable. So meaning, in your noble gases, they have this full shell. So meaning, if you are helium with atomic number 2, so this is your outer shell. Meaning your outer shell is complete, meaning it has 2 electrons there. Now, let's continue. So this makes the noble gases very unreactive. Unreactive meaning they don't cause chemical reaction because they are stable. Stable means balance. Let's continue. Now, the atoms of other elements. So what are these other elements? So this is your group 1 until group 7 elements. So the atoms of other elements have incomplete outer electron shells. So it can be that, like for example, in your first ring, it has only 1 electron. In your second ring, maybe it has only like 1 electron, or maybe it needs 1 more electron or 2 more electrons. So meaning they are incomplete. They did not reach these 8 electrons and 8 electrons here. So as a result, so they are unstable. Unstable meaning they are not balanced, so meaning they can cause chemical reactions. So by forming bonds, the atoms of these elements are able to have filled outer shells and become stable. So meaning it's either one element will give its electron, that is your ionic bond. If you haven't watched the ionic bond videos, I want you to go back to the previous video. And there's another bond called like your covalent bond. Covalent bond wherein the electrons, instead of giving it, they are just sharing it. So just a review of your ionic bond. So we have here 2 elements here, elements A and elements B. Remember that in your ionic bond, you have your metal and non-metal bonding. So in your metal here, so we have here, like for example, your sodium, and your non-metal here, we have your chlorine, wherein what happened is that in your atom number 1, which is a metal, so it will be giving away its electron to atom number 2. So meaning it's okay for this atom to give its electron because it has only 1 valence electron. So meaning if it gives already to your atom number 2, so this A here will become complete, right? And then what will happen in your atom number 2? So it will accept, it will receive the electron from your atom number 1. So as a result, so look at it here. Since atom A gave away its electron, so the charge becomes positive. So meaning A has more protons than electrons. In here, B here becomes negative because it receives the electron from atom A. So meaning it has more electrons than proton. Now let's go to your second type of bond, which is your covalent bond. So what is a covalent bond? So it is a bond between two non-metals. Please take note, two non-metals. So this type of bond is a sharing bond. So let's try to look at the next slide. Now, looking at your periodic table, so you can see there that your chlorine is a non-metal. So chlorine is a non-metal. So we have here two examples here, two chlorine, so they are two non-metals here. So let me show to you what does its like electron model looks like. So in your chlorine here, as we all know, it has a valence of 7 because it belongs to your group 7, right? So meaning it needs one more electron to become complete, right? So if we count here 1, 2, 3, 4, 5, 6, 7. So do you still remember that your second ring, this one, the second ring, it needs how many electrons? It needs 8, right? So in your chlorine, it has only 7. So it needs one more electron to become complete. However, in your covalent bond, this is more of your non-metal and non-metal. So if you are chlorine and if you will be giving it to another chlorine, so this chlorine will be happy. However, this chlorine will become sad, right? So they want the two chlorines to be happy. So how are you going to do that? So instead of giving it, you're going to share it. So always remember that in your non-metal elements, like your chlorine, so they usually need one or two electrons to fill their outer shell. So this is your outer shell. So their outer shell needs only one, only one. So as what I've told you, so this chlorine need only one, right? So they can do it by sharing the electrons. So this is what your covalent bond look like. So instead of giving away their electrons, so they will just share it. So if you're going to count it now, so starting from here, so you will have like 1, 2, 3, 4, 5, 6, 7, and 8. Also with other chlorine, we have your 1, 2, 3, 4, 5, 6, 7, and 8. So both of them, so both chlorine now have like 8 electrons in their outer shell. So meaning this chlorine is now happy. This one, this chlorine is also happy. So again, in your covalent bond, they are just sharing the electron. So how do we write the covalent bond structure? So there are two ways. So number one is by using your Lewis dot diagram. So do you still remember your Lewis dot diagram? Okay, so in your Lewis dot diagram, so you can do like this. So 1, 2, 3, 4, 5, 6, 7. So just move this one closer. So if you have here your CL, so let's use the green one. So you have your 1, 2, 3, 4, 5, 6, 7. So this area here is your shared electron. So another way to write your covalent bond is by using this dash here or this line. So this line here represents this area. Okay, this area that I encircled. In naming your covalent bond, so they have similarity in your ionic bond. So if you look at rule number 1 and rule number 2, for the first element, start with the element name. And for the second element, start with your IDE name. So they are just similar in your ionic bond. Like for example, sodium, the first element, then chloride from the word chlorine. So instead of writing sodium chlorine, so you're going to write sodium chloride. So chlorine ends now with the word IDE. So again, your covalent bond have the same rule with your ionic bond for rule number 1 and rule number 2. However, in your covalent bond, there are extra rules. Rule number 3, you use prefix to show how many atoms of each type are there. So I will show this one in your next slide. Rule number 4, don't use mono. Mono means 1 on the first element. And rule number 5, if you have AO or OO in the word, turn it into just simply O. So M3, I want you to write this one in your notebook so that when we go to next slide, you can review the rules as we learn about how to name covalent bond. So here are the prefixes of your rule number 3. So 1 means mono, 2 means di, 3 means tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. If you remember your polygons, right? If you still remember the word pentagon, hexagon, heptagon, octagon, nonagon, decagon, so they're just the same. We are using the same prefix in learning your polygons. So let's look at our first example. So in our first example here, we have this N2O3. So how do we name this covalent bond? So again, please look at the elements first. Okay, when you name bonds, so you have to identify first, is it a metal and non-metal or non-metal and non-metal? So for our case, so nitrogen here is your non-metal, this one is non-metal, and this one is also a non-metal, so we will use covalent bond. Now let's apply the rules. So rule number 1, so first element, start with the element name. What is this element name? So this one is your nitrogen. And what is our second element? This one is oxygen. Now, in your rule number 2, for the second element, so oxygen is your second element, so start with the name IDE. So your oxygen is not oxygen anymore, but we have to change oxygen into oxide word, because rule number 2 states that you have to change the second element and ends with IDE. So the second or the name of this element is the nitrogen oxide, but we are not yet finished. For rule number 3, we have to use the prefixes. So we are going to look at the numbers here. How many nitrogens are here? 2. How many oxygens are here? 3. So looking at the prefixes, there are 2 nitrogens. So we are going to write dinitrogen, because di means 2. How many oxygen? 3. So we are going to use tri. So this one. So the name of this element is dinitrogen trioxide. So this is the final answer. Now you can pause this video and think of the name of this compound. Okay, let's check. So again, what's rule number 1? So we have to write the element names. So we have P. What is P? We have your phosphorus. And the second element is your sulfur. So using your second rule, change it into IDE. So your sulfur becomes sulfide. Now, the next thing to do is we have to look at the number of atoms. Rule number 3, how many phosphorus? 4. So we are going to use tetra. And how many sulfur are here? They are 10. So we're going to use deca. So this is now your final answer. Okay, this time you pause the video and think of the correct answer. Once you're done, you can click the video again. Okay, let's check your answers. So, rule number 1, start with the element name. So C, what is C? C is your carbon. Second element is F, your fluorine. Okay, very good. So again, fluorine becomes fluoride. Now, let's look at how many carbons are there. There are 1. So again, what is rule number 4? Do not use mono on the first element. So meaning, do not write mono in front of your carbon. Okay? So let's go with element number 2. Your fluorine now becomes your fluoride. How many atoms of fluorine are there? There are 4. So we are going to write the word tetra. So carbon tetrafluoride is your final answer. Okay, let's check this another example so you can pause this video and think of the correct answer. Okay, let's do this one. So we have your Cl2O7. So the first element is chlorine. And your second element is oxygen, which will become oxide. So now, how many chlorine are there? How many chlorine atoms? There are 2. So we're going to use dichlorine. Now, how many oxygens are there? So there are 7. So we're going to use hepta. Now, look at your rule number 5. Your rule number 5 states that if you have AO or OO in your name, so you have to turn it into O. So this is the AO that I am talking about. Okay, so this AO will become, simply write O. So meaning your heptaoxide will become your heptoxide. So the final answer is dichlorine heptoxide. And finally, this is our last example, so you can pause this video to think of the correct answer. Okay, let's check your answers. So again, what is rule number 1? So start with the element name. So C here is your carbon. And rule number 2, oxygen becomes oxide. And let's try to check how many carbon atoms are there. There are only 1. So meaning, rule number 4, do not use mono on the first element. So do not write mono in front of your carbon. Next, let's check how many oxygen atoms are there. There are only 1. So this time we are going to write mono in front of your oxide. Now, look at rule number 5. Rule number 5, if you have AO or OO, turn it into O. So meaning, so we have here your OO here. So this OO here will become a simple O. So our final answer will be carbon monoxide. Carbon monoxide. This is our final answer. So we are finished with your covalent compound. So please do the worksheet and upload it in your Google Classroom. Thank you for listening to our lesson M3. So I hope you understand about covalent bond. So again, thank you for watching and have a good day.